Administering data import and export. The ability to take data out of MySQL Server for analysis in a third-party application or perhaps even to import into another database system is crucial. It's a crucial skill that every MySQL DBA needs to have. Here in this final nugget of the series, I'm going to show you A, how to import data into MySQL Server from various plain text file formats. We'll then look at doing just the opposite from within MySQL, how to take table data and use the select statement to output that data into, again, a portable file format for use with, well, just about any business intelligence need you have, actually. And then we'll wrap up by looking at two external utilities that are bundled with MySQL Server, MySQL Import and MySQL Dump, both of which provide us this really nice import-export capability. Let's get to work. Before we get into the meat and potatoes of importing and exporting row set data into and out of MySQL 5, let's briefly review a couple commands that we've used elsewhere in this Nugget series. And the reason why I want to formally introduce these again to you now is so we can compare and contrast them with the tools that we're going to learn throughout the rest of this Nugget. You'll remember that at various points in our training, we would, from a shell prompt, in other words, from your Linux command prompt or your Windows command prompt, you can run the MySQL client command with less than and then a path to a script file in order to import one or more SQL statements directly into MySQL from the operating system. The equivalent way to go is once you're logged into MySQL client, there's the source command where we can pass in a partial or a fully qualified path to, again, a script file to absorb the contents of that file and parse the incoming SQL in the MySQL server. Now, the deal or the similarity between both of these techniques is that we use these to import or absorb SQL statements, what's called a batch file, or also called a script file, into MySQL server. Again, I just wanted to compare and contrast because although we're going to use both of these commands, actually we'll just use this first one in the demo for this nugget. Both of these are used to import script files, not row data. The majority of this nugget is concerned with how do we, for instance, back up the contents of our database into a portable format that we can then take off and archive or share with another database system and so on. And that row data is going to, as we're going to see very briefly, manifest itself typically as a separated value plain text file. All right, so you use these to bring in SQL scripts, and then the commands I'm about ready to show you right now are used to import and export row data. First, let's examine how to import data from files into MySQL Server. So you might have an export file, some kind of separated value file, like maybe a comma-separated value file or a tab-separated value file that you've exported from Oracle, from another MySQL server, from SQL Server, heck, perhaps even from an application like Microsoft Excel. And you want to now absorb that row data into MySQL Server and slam dunk those rows into a destination table. Well, from within MySQL Server, the way you go about doing that is using a command expression called load data in file. So it's presumed that we've logged into MySQL with a user that has enough privilege to perform inserts on the destination table. And the command syntax for load data in file is pretty straightforward. We simply specify load data in file. Note that in file is one word and not two. And then we use single quotes, remember that's our string delimiter symbol in MySQL, to present a qualified, fully qualified or partially qualified, depending upon where you are in the operating system, path to a destination text file. So the first code sample I'm giving you is obviously from a Windows operating system where we have a file called datafile.txt stored in our stuff folder on the C drive. And in the second code example, this is a Linux Unix machine where we want to absorb the contents of data.txt that's stored in var MySQL stuff. All right, so far so good. Now, one note about Windows directory paths. You'll recall very early in the course when I showed you how to install the sample databases that are available, you can use the source command once you're logged into MySQL to path out to the location of your destination script files. I mentioned at that time that on Windows operating systems, instead of using the backslash, which is traditionally the path delimiter in Windows OS, we have to, in MySQL, reverse that backslash and use the forward slash. At that time, I didn't tell you why. Now I want you to know, because now that you have a pretty good grasp of getting around the MySQL client, I hope by now you're comfortable with using escape characters. For instance, you'll remember \C is how you can back out of a command sequence. \Q enables you to quit out of the MySQL client. Therefore, the \/ character is a reserved character in MySQL, and this is why when you're doing Windows-based directory paths, you have to use the /. So keep that in mind, all right, friends? After we say load data in file and path out to our file, we simply complete the expression by saying into and then the destination table name. Therefore, importing data is on its face, at least syntactically, a pretty darn easy operation. Now, by default, MySQL expects the file to be a tab-separated value text file. And that means that you have your columns separated with a strike of the tab key on your keyboard. And also, MySQL by default expects that a new line is your termination. New line simply refers to each line in the text file denotes a separate row. Third, all columns are going to be expected in that file, such that if we have a tab-separated value file that contains 4 values separated by tabs, well, we can expect when we run load data in file and apply that file to a table in our database, that that table has those 4 columns in the designated sequence. Therefore, there's some homework that you'll probably have to do in terms of creating the destination table, or at the very least running describe so you know what the data types and the columns are that are expected, and then tailoring your separated value file specifically to accommodate that. You'll also remember from earlier nuggets that you can get away, possibly, on not including all columns in your separated value file, and what'll happen is for any missing columns that aren't specified in the file, those values will be set to their defaults if you do have a default set for the column, or if it's, say, a key column that has the auto increment property, well, that'll just automatically get incremented out of the box for each row, so you wouldn't have to explicitly state those values unless you already had them in your separated value file. Now, you'll notice at the bottom of this whiteboard I give you a little bit more robust syntax, just in terms of fields terminated by. There are some additional clauses where you can specify, for instance, in this case, comma rather than tab as your separator. And if you have another way to terminate new lines, maybe a carriage return rather than a line feed, you can specify that as well. To get the full syntax, I would encourage you, as always, to visit the MySQL reference manual and look up the syntax of the load data in file statement. Whereas for your exam and also for your real-life experience as a MySQL DBA, you have to understand and master the load data in file to do data imports, you also, on the other hand, need to understand the into out file clause of the select statement to perform just the opposite action. Now let's take a look at exporting data from MySQL Server into a separated value file. Again, the syntax is pretty straightforward, pretty logical, and you should be able to master it in short order. For instance, let's look at code sample 1 that says select star into out file, and then we have our single quotes enclosing the string to a file name or perhaps a fully qualified path, depending upon where you want that file to end up, from the destination table. Now, one gotcha when you're exporting data from files, and this is especially true on Linux Unix systems, the owner of that file is the server. So if you're not logged on or if you don't have administrative access to the MySQL server, you'll want to inform those who are that they may need to change ownership or change permissions on that destination file because, like I said, this file is being created in the host operating system by MySQL server. So that ownership chain is going to be preserved. Let's look at the second code sample here. Again, I've given you a little bit more verbose of a statement to show you that, again, we can throw in these terminated clauses just like we could with our load data in file statement if the file that we want in this case isn't a tab separated value file where each row in the file is denoted by a line feed. All right? So here we're selecting everything, all rows, all columns, from the employees table, and we're sending that out to temp employees.txt. And here we're changing from a tab-separated file to a comma-separated file. By default, your values in your out file will not be enclosed by parentheses or quotation marks. If you do want to quote the values, the column values in each row, you can specify enclosed by, and then lines terminated by. There's a series of escape characters that you might want to take a look at in the reference manual to look at the different options that you can specify to denote different line termination schemes. So therefore, importing and exporting is just as easy as understanding the load data in file and the select into out file statements. Pretty straightforward, isn't it? Now let's have a look at the command line tools for data import and export in MySQL Server. You'll recall that our justification for using some of these external executable program files is for, number one, scriptability. You can write a script that calls the particular command line tool to run several operations in a batch function. Another instance is where you're simply in an operating system and you either don't want to or are unable to log into MySQL Server. Regardless, I'm going to show you two of these tools and we're going to use them in the demo. The first presents a command line interface for load data in file, and that's an executable called MySQL Import. Simple deal with this. It works just like load data in file to load data from the file system into a destination table. So you see here on our shell prompt, we can run, just like we can with any of these executables, the name of the program, any options, and then the target of those options. So MySQL Import supports several different flags. Here the sample syntax I'm giving you shows field terminated by commas and line separated by returns, carriage returns. And then we have our target of that file. The file is employees.txt and the target database in this case is testdb. The other appropriate command line tool for this nugget is MySQL Dump. Now, whereas MySQL Import takes data from the file system and brings it into the database, MySQL Dump is just the opposite. I kind of wonder to myself why the MySQL team didn't call this tool MySQL Export. After all, I think it would be a lot more obvious considering we have MySQL Import, but for whatever reason we have MySQL Dump. And this tool is used to dump table contents to files. A lot of DBAs will use MySQL Dump as an easy-peasy way to perform file-based data backup, or backup either for archival or possibly for data transfer to another MySQL server or to another database system entirely. Now, it's beyond our scope to talk much about disaster recovery. That's covered elsewhere in the DBA exams, which I'm developing for CBT Nuggets. So make sure to keep an eye out at the CBT Nuggets website for those products. But I'll just say right now that MySQL Dump gives you file-based backup. In other words, what you're going to have at the end of the day with a MySQL Dump statement is a text file that contains the rows and a .SQL script file that contains your object definition. For instance, if we backed up a table called employees from one of our databases, we would have an employees.txt file that contains all of the row data in a tab-separated format file, and we would also have a .sql file that contains the create table statement and all of the column definitions and engine declaration and basically all of the stuff that you get if you run a show create table for that table. And what's nice about this is you can then use these two files to fully restore that table back to any database. You would simply load in the script file to create the table, and then import the text file to populate the rows into that table. And in MySQL, the file-based backup that's given to us by MySQL Dump is an alternative to doing what's called a binary backup, where you can literally just use Windows backup or your OS backup tool or a third-party backup tool to take the data directory files, the actual data files, the MYI files, for instance, in MyISOM, or the IB data tablespace file if you're using InnoDB, and literally take a hot copy of those files. Anyway, that's beyond our scope. For now, let's look at how to use MySQL Dump with some other utilities to perform data exports and imports. Code sample 1 shows us from the shell prompt running MySQL Dump, the database in question, and then greater than to signify an out file, and then a full path or just a file name to a destination script file. Now what this is going to do is back up the entire database to an SQL file. You're going to see in the demo we're just going to use MySQL Dump to back up a table, and that's going to give you the two files like I have over here. But just for the sake of completeness, and actually this is what step 4 or code sample 4 is showing too, you can run MySQL Dump with the all databases command to take every database on the server rather than a specific one and slam dunk all of that DDL and row data into a single .SQL file. And then you see on code samples 2 and 3, these are just two equivalent methods for importing that backup. So for instance, once we back up testDB, if we want to restore it on another server, from the shell prompt we can simply use our less than syntax like we showed you before when we invoked the MySQL client, and we would specify a destination database name. Or alternatively, you can use the source command either from within MySQL, or as you see here, the E switch at the MySQL command prompt when you're launching the MySQL client program enables you to load a script file directly without actually logging into MySQL and mucking around within it. So this is going to go out on a Windows system and grab this backup file and apply it to a target database named testDB. Alrighty then, in this final demo of the course we're going to do, you guessed it, some data imports and data exports using the various and sundry MySQL extensions to the SQL data access language to do it, and we'll also use the MySQL Dump and MySQL Import utilities as well, just to make sure that you're fully covered with all of these technologies. Let's rock! In this demonstration, we're going to work with importing and exporting data in MySQL 5.1. We're on Ubuntu Nugget here, so we're working obviously in a Linux environment. It's fine. The only difference between this and Windows, of course, is going to be our directory paths. All right, so here's the schema for this lesson, everybody. What we're going to do is, first of all, log into MySQL, as you see here, and we're going to use MySQL Dump to take the city table from the world database and bring it out into the file system. So to just verify that it's there, we'll use world and show tables, and sure enough, there's our city table. So if, for instance, we wanted to grab everything from city, I'll just run a simple query here to show the first 10 rows and bring this data out into the file system. How can we do it? Well, let's do a \Q to get out of MySQL. And if we're going to do this export from the file system, which I am right now, we're going to use MySQL Dump for that. Let me switch my tab because I have another terminal shell open where I've SU'd and become the root super user. If you're not root on Linux, you'll have to run the tool using sudo to make sure that you're starting MySQL Dump or MySQL Import to do an import with administrative privileges. Alright, so we'll simply say MySQL Dump, and then we'll use the tab parameter to specify our destination. So if we want to throw the city table from the world database into our temp folder on this machine, we simply specify that path. We specify the source database and then the source table. It's as simple as that. So if we navigate to temp, we can see now we have city.sql and city.txt. So why don't we cat city.sql and show you what it looks like. We see, just like I promised, the SQL file contains all of the SQL statements that are required to build that object back when we do an import. So you see MySQL Dump, host, database, there's metadata. You notice that we're using a comment to denote what are comments and what aren't. And then finally we get the meat and potatoes here, drop table if exists, and then we're creating the table itself. Here's the actual definition of that city table. The other thing we can look at is city.txt, and this has quite a few rows. You notice again it's a tab-separated text file, such that each column in the city table, whatever these columns are being separated by a tab character by default. Just for grins, let's come back over to MySQL. Let's drop the city table. So if we show tables, we don't have that table anymore. So the next question is, how can we bring that table back? All right, therefore we don't have the city table anymore. The question now is, how can we bring back that data? We know that there are two files, a .sql script file that contains the definition of the table and a .text file that contains the rows. You'll remember at the beginning of this nugget I gave you the different syntax or the different commands that are required to import an SQL script versus importing row data. In other words, we can't just come to an elevated command prompt and run MySQL Import to bring in a .sql script file, because MySQL Import is expecting a delimited text file that contains row data. And I'm guaranteeing you, if we run MySQL Import, in fact I'll try it, specifying the world as our target database and city.txt as our file that contains the rows. Now notice that I don't have to qualify the path to city.txt because you'll see from my terminal prompt I'm already in the temp folder that contains this file. But when I submit this, note I get an error. Table world.city doesn't exist. Well, that's to be expected. We deleted the table or dropped it from the database. Therefore, what I'm going to do is come back over to MySQL. We'll \Q to come back to our prompt. And actually, I could do this on the other tab, but what the heck, we're already here. Therefore, to create the table by using our city.txt backup file, we can, and you'll notice the $sign. I'm not in an elevated prompt, and I'm just issuing sudo just to make sure. We'll run MySQL target database name less than, and then the path to the file. If I can get my typing correct, that is. It's not in var, it's in temp. All right, so that appears to have worked. We can verify this, of course, by logging into MySQL and showing our tables. Good, so there's our city table. And again, just for completeness, we'll run a show create table to verify that the object exists. To sum up what we did, we dropped the table city from the database. We ran MySQL Dump in order to dump the SQL file and the text file. And then from a shell prompt, we ran MySQL specifying the target database and then bringing in the path to the SQL that contains the definition. And now we've got the database table defined in MySQL. Next thing we can do, and I'll come over to my elevated command prompt over here so we don't need to worry about sudo. We can run MySQL Import just like we did before, specifying the target database and the text file that contains those definitions. Now you notice that we got an error just specifying the name of the file. As you can see, I've messed up here. I've used var. I don't know why I keep using that. By specifying MySQL Import target database name and then qualifying the path to our text file, we get a response that we've brought in 4,079 rows. Good deal. So now we can, from within MySQL, run a select from that table. I'll say limit 20 in this case, and our data's back. Next, why don't we take a look at the select star into out file and load data in file methods of doing data export and import respectively. We're already logged into MySQL, so let's run a show tables again. And let's say in this case we want to export the country table from the world database into the file system. I just showed you how to do this from the operating system by using MySQL Dump. Now let's, from within MySQL, use the select star into out file command to do the same thing. And all we have to do is use a quoted path, again I'm going to use temp, to the name of the file. I'll call this country.txt. And if we wanted to throw in fields terminated by, lines terminated by, that would be fine. I'm not going to do that though. I'm simply going to specify from country. Tells us query was okay, 239 rows affected. So therefore, if we come back to our temp folder and run a directory listing, we now have a country.txt. If we want to view the contents of that really quickly, we can. Looks pretty ugly here, as you see, because there's quite a few columns. Actually, we might be better off running this from gedit. So in gedit, why don't we open the file country.txt. Wow, that's still pretty tough to look at in a text editor. You'll probably want to put this into a spreadsheet type application, OpenOffice or whatever on Linux, Microsoft Excel on another machine. All right, well, I'll tell you what we're going to do here is select everything, and let's just create our own file from scratch, shall we? We'll do a save as, and why don't we call this new table data. Actually, let's just call it new table.txt. And I've browsed out to varlib MySQL world. You'll remember that on Linux systems, varlib MySQL is the default data directory. And let's just go ahead and put this file in the world subdirectory. You'll remember that under your data directory, there's an additional directory pertaining to every database on the system. And we're going to save new table.txt here. The reason for that should become, or will become, pretty apparent very shortly. Because the next thing we're going to do, actually, is open up another file. This one, our friend city.sql. You remember how that was created with MySQL Dump a few minutes ago. I'm back in temp, by the way. We'll open up this bad boy, and what we'll do is create a simple table definition. We'll remove just about all of the text in the file, and just leave the raw potatoes here, and we'll make some simple edits. We'll call this table new table. We'll leave the ID column. We'll leave the name column. We'll get rid of all the other columns. We'll specify ID as our primary key. That's fine. And what we'll do is save this in, again, varlib MySQL world. Again, we'll call this new table.sql. Good deal. So you see what we've done? We've actually fashioned our own SQL script file here that's going to create a table named new table that has two columns, one an ID and two a name that's set for char 35. Why don't I make this varchar just to be safer? And then if we mosey on over to new table.txt, we can create our own tab-separated file, and so on. So I just have 1, value 1, 2, value 2, 3, value 3. Easy peasy. And you know we've got both of those files stored in the file system in the appropriate folder. And if we run a directory listing in the world database, we can see we have new table.txt and new table.sql. So we've defined a brand new table and we have some rows. The whole purpose of that exercise, of course, was to set us up for using the load data in file statement to bring in that row data. So to bring that new table.sql file in from our elevated command prompt, we can use MySQL, the name of the destination database, less than, and then the name or path to our file. That worked just fine. So we can just directly log into MySQL, use the world database, and verify that the new table exists, which it sure does. So again, let's use show create table, new table, and there it is, our ID column and our name columns all well and good. The coup de grace now is to use load data in file. And of course, to do that, we specify load data in file. Well, actually, I don't need the path since by default, MySQL is going to use its data_dir system variable to locate the file. And since I'm going to specify, again, using world, just in case I haven't done it, to make sure I'm attached to the world database, I can just say load data in file, new table.txt, into table, new table. Of course, sometimes it's the simple things. We have to put our quoted identifiers around that string, and we're good. Query OK, 3 rows affected. So if we select star from new table, we have our data safely and firmly committed to our database. All well and good. Administering data import and export review. In this final nugget, we looked at some interesting stuff that falls under the category of BI, or business intelligence. I showed you how to take data and import it from the file system from various delimited text files into MySQL. We looked at the opposite occasion as well, where we're taking data from one or more tables or databases and exporting that into file format, which is useful for transfer purposes or for archival backup. We also went outside of MySQL client and looked at 2 external program files, MySQL Import and MySQL Dump. I hope that this has been informative for you, and I'd like to thank you for viewing.